In the world of data, how you actually organize everything, well, it's the whole ballgame. It really is the difference between getting an answer in seconds versus minutes, or seeing a clear business insight versus just a jumbled mess. So today, we are jumping into one of the most fundamental choices in data architecture, the huge showdown between the star schema and the flat table.
Okay, so to get us started, let's look at a real-world cry for help from a data pro over on Reddit. Just try to imagine this. It's your first day, and you get handed a single, monstrous table. It has 127 columns, and it's trying to describe the entire business. This isn't just some crazy hypothetical. It's a daily nightmare for a lot of folks, and it perfectly sets the stage for the problem we're going to unpack.
All right, so we're going to frame this whole thing like a championship fight. In one corner, you've got the heavyweight champion of simplicity, the flat table. And in the other corner, we have the elegant, technical reigning champ, the star schema. The prize they're fighting for? Nothing less than data architecture supremacy. Let's get ready to rumble.
First, let's set the stage a little. We are living in a complete data explosion. I mean, every click, every sale, every single interaction, it's all generating more and more information. Getting fast, reliable insights from this absolute ocean of data isn't just a nice-to-have anymore. It's a massive business advantage. And the key to unlocking it is the structure. I want you to think of a data warehouse like a big restaurant kitchen. It's the place where you take all of your raw ingredients, that's your data from sales, from finance, from marketing, and you turn it into something valuable, right? Business intelligence. So how you organize that kitchen, which is your data model, that's what's going to determine how fast and how well you can serve up those insights.
So let's meet our first contender, the flat table. You might also hear it called the one big table or a denormalized model. This is the powerful, no-nonsense challenger that can pack a serious punch, but only in the right environment. The idea behind it is actually super simple. Just put everything you could possibly need for your analysis into one gigantic table. So if you're looking at sales, you don't just have the sales number. Nope. You've got the customer's name, their city, the product name, its category, the store location. It's all sitting there in the very same row. It's the whole shebang, all in one place.
So what's the big appeal here? Well, first off, it's simple. Your users don't have to wrap their heads around connecting a bunch of different tables. It's all just right there for them. And second, and this is absolutely crucial, it avoids what we call complex joins. That's just the process of linking data from multiple tables. For some of the newer databases, especially these massively parallel processing systems, avoiding those joins is a huge win for performance.
But, and it's a big but, the flat table has some really serious weaknesses. I mean, think about it. If a customer's name is in 1,000 different sales rows, you're storing it 1,000 times. That's a ton of redundant data. And what happens if they get married and change their name? Well, now you've got to update it everywhere, and that is a data integrity nightmare waiting to happen. This model can also be super brittle and hard to scale when the business starts asking new questions.
And this right here just nails the point home. This quote is from that original Reddit post we talked about. This person isn't just talking theory, they are living the pain of this system. When your table is 127 columns wide, trying to add the 128th column, or even just handing the project off to a new teammate becomes this unbelievably difficult task.
Okay, now let's turn our attention to the other contender, the star schema. This is the classic, the elegant, the reigning champion of traditional data warehousing for literally decades. It's built on a foundation of pure logic and organization.
So here's how this one works. Right at the center of everything, you've got a fact table. This table is lean and mean. It only contains the numbers, the business events like sales amount or quantity sold. Then, surrounding this fact table like points on a star, you have your dimension tables. These tables give you all the context, the who, what, where, and when. So you'll have one table for customers, one for products, another for dates, and so on.
The real beauty of this model is just how efficient and clean it is. A customer's name? It's stored in exactly one place. If they change it, you update it in that one spot. That saves space, and, way more importantly, it prevents a ton of errors. It's also incredibly scalable. Need to start tracking info about your stores? No problem. You just add a new store dimension table and link it up. Easy.
Of course, it's not perfect. It's definitely more complex for the end users, who now have to figure out how to join tables together to get the full picture. And those joins, which are the absolute heart of the model, they can be a total performance killer on certain database engines that just weren't built for them.
This whole philosophy is just perfectly captured by another comment on that Reddit thread. It really shows that the star schema isn't just a technical structure, it's a way of thinking about and modeling the business itself. It's about connecting the events to the context.
So we have our two contenders. Both have really clear strengths and weaknesses. So, who wins? Well, it turns out the winner isn't decided by the schema alone. No, it's decided by the arena, the underlying database technology where the fight is actually taking place.
And this right here is the central idea from a really fascinating performance analysis published by MDPI. They ran a whole battery of tests and found that you simply cannot declare one schema as universally better. The performance is 100% dependent on the database architecture you're running it on. Okay, now check this out, because this is where the hard data comes in. The researchers tested both schemas on two major types of databases. On your traditional columnar relational databases, think Amazon Redshift or MariaDB, the star schema was the clear winner. But on the NewSQL or hybrid systems like SingleStore and TDB, the flat table just crushed it. And here's the twist. Even within the same category, you had exceptions, like IBM DB2, a columnar database that actually preferred the flat table.
So, why the huge difference? Well, it all comes down to how these two fight rings are designed. Your traditional columnar databases, they are absolute masters of the join. They are built from the ground up to efficiently connect separate tables. But on the other hand, a lot of these modern MPP and NewSQL engines, they're built for parallel processing. They hate joins. They see them as shuffles, these operations that force data to move all over the place, creating a massive bottleneck. For them, a pre-joined flat table is way easier to chop up and process in parallel.
And a database like Vertica is the perfect example of this. I mean, it was literally built from the ground up to take advantage of the very separation of data that a star schema provides. It's what makes those joins, those connections between tables, incredibly fast and efficient.
So, after all the rounds, after all the back and forth, how do you actually pick your winner? How do you choose the right champion for your data needs? Let's break it down with a final scorecard.
Look, if there is one thing you take away from all this, let it be this. There is no single right answer. There's no knockout punch. Anyone who tells you to always use a star schema or always flatten your tables is missing the most important part of the picture. The best choice is a strategic one that depends entirely on your tech, your users, and your goals.
So here's the judge's scorecard, plain and simple. You should probably choose a star schema if your main priorities are data integrity and long-term scalability, and you're running on a classic columnar warehouse like Redshift. But you should lean towards a flat table if your top priority is making queries dead simple for your users, and you're using a modern MPP engine that just hates joins. And the golden rule, the most important rule of all, always benchmark. Test both models with your own data, your own queries, and your own tech stack.
And that really just leaves us with one final question to think about. This data battle is not over. It is constantly evolving as new database technologies come out. So I want you to take a hard look at your own data architecture. Is it really optimized for the arena it's fighting in today? And is it ready for the next round?